Hi guys, today I would be discussing the Codeforces Round 746. So basically, I'm sorry for not making videos from last 1 month, but because my midterms were going, so I didn't have much time to give into this. So basically, I would start with question C because in A, B, and C only question C was something which included some type of DSA and was not only constructive thing, which generally code forces are. So I think C would definitely make you understand some things and would make you learn more. So I I'm assuming that you would have already read the question. So let me jump into the whiteboard and directly explain. So basically, you need to cut at least one edge from the graph, which is actually a tree in this case, and at most k minus one edges, and so that all the components which you get after cutting the edges have equal XOR among them. For example, suppose we have a tree like this, something like this, and basically if you cut this, then component this should have a, if this component has a XOR value of x, and if you also cut this component, then this component also should have a XOR value of x, and these two nodes should also have a XOR value of x. Now we need to do some observation for solving this question. So we do have one property of XOR which says that if a1 XOR a2 XOR a3 up till XOR an is equal to 0, then you could put the bracket onto any number and the rest of the sequence could be XORed with that to get you 0. Suppose you take a1 and just XOR it with XOR of every other element a2, a3 to an, and this doesn't need to follow any condition. You can take any two, any three, any number, any number of times, no problem. Just you could you just need to distribute them into two sequences, such that you, after taking the XOR of them, you would definitely get a 0. So using this property, we can say that if after doing XOR of all the elements given in the array, I get a 0, then definitely I can just choose any one edge and just cut it. If I just cut this edge, then I'm damn sure that this value, the XOR of this value, which is individually this value only, and the XOR of this whole tree would definitely get me a XOR value equal to this value. So if the XOR value of all the elements is equal to 0, then the answer is definitely yes. No issues on that. But if the XOR value is not equal to 0, and it's suppose it is something like y, then what you need to understand is that though it is mentioned that I need to that I may cut at most k minus one edges, but what I can see is that I would have to make at most two edges if the answer is possible. So what I am trying to convey is that if the XOR is y, then if I distribute the whole tree into three components of which are having XOR equal to y, then I'm done. So basically I just need to find two edges so that I can cut them and I get a XOR value of y. This can be easily implemented by some observation and some intuition. Let me say that also. Suppose you are having a tree, and suppose this value is y. Now you just care. Let me make it more. Now suppose the XOR of these three values is y, which you want for every component to exist. Now, if I cut this edge and recalculate the all the subtree values with XOR, and if I again find a subtree with the value having XOR y, then I could cut that value also, and I'm damn sure that as there were definitely either three or more than three, which is an odd number, that is 3, 5 or 7. So I'm damn sure that after removing these two, I would be having a odd number of y's, so that XORing them would definitely make me a y. So the third part, which would be remaining, would definitely give me a cumulative XOR value of y. So definitely I can disconnect two edges and get them. So now why I need to choose the deepest node only for choosing the first edge which I need to cut. Now suppose, for example, I have this value as y, this value also has a y, this value also has a y, and there is some rest. Now, if you choose this y only, you found this y just once, you cut this edge, and now if suppose every other node if every other node's value existed two times, like 1 existed two times also, 2 existed two times also, 3 existed two times also, so this whole cumulative value would come out to be 0, as every element was equal to 2, and as this value was y, because this and this XOR's value would definitely cancel out, and this value would be y. So the main node, which would be a rooted tree in my case, its value would be y, but it would not be due to many cumulative y's. This one is y, and this whole, all these are zeros, so the y XOR with all the 0, 0, 0, this gives me y. So if I just cut this y, I would not have any option to generate one more y, so that I can cut it into 3 segments. So that's why I need to make sure that I cut the deepest subtree for which I am having the XOR value of y. So this would ensure me that after cutting this y, if there was a possibility that there was any other subtree having XOR value of y, then I could definitely find that subtree and I would get my answer. So I think I have explained it clear enough. Now let me move on to the code for a more better explanation. Just one second. Yeah. So basically, this is just the input part. This is n, and this is the k value which I have written as q. So I'm just doing the XOR of all the values, and this is just the edge input. If the XOR value is y that I already mentioned, then output yes. This y and n is defined here. So then output y. Otherwise, if that's not the case, then I would do a DFS 100, where this one is my source node, this would be my parent, and this would be for calculating the distance of every node. Because what I have said you in this tree, that I would need to find the deepest XOR value of y which would be there. So I need to find the distance of every node from the root node also. So that's why I would be doing these things. So this is just a simple DFS. And what, let me explain all these also. So this XR value stores the subtree. This XR value stores the XOR of all the nodes of the subtree of that node. So what I would do is that this CT plus 1 is the distance increment, and this XR XOR is equal to XRI. XRI is for the XORing of all its for all the children of any node. So after I would assign, I would just go on to its children, calculate its XOR, and then finally XOR it with the source vertex. So this part is done. So after this, I would just check where it is. Yeah. So I would just check if the XOR value is equal to the remaining XOR values which I have got from here, and increment the counter, and this part is just to check the deepest XR value which I would get. So if the CT is equal to 0, that is I haven't got any X value which is present in the in the whole tree. Basically this I am starting with 2, so there would be a residual only. If that is 0, so then the output is definitely no. But if that's not the case, then I would just initialize first all of the XOR values is equal to 0 to actually reset the values. And then what I would do is that as I am storing this j value also, I would be calculating this parent of j. This is just for the deletion of it. Suppose this value was y, then for deleting this node, I just need to do one thing. As this is a tree, there is no cycle. So I'm damn sure that if I disconnect any edge, then its whole subtree would be disconnected from the main tree. So I just need to disconnect this edge and I'm done. So if this value is j, I need to find the parent of j, which is this value. So this is also done. This is m is equal to parent of j, and this I would find the position of this m in the this vector of j. So this and this erase function works in order of n, so there is no problem as I am using it only 2 times and not in a loop. And then I would also find this value of j in the vector of m. I would also find this and then erase these two. Then I would call the DFS, calculate the XOR value again, and if there exists any subtree which is having XOR value is equal to sum, then I would definitely output yes, otherwise no. And after and for outputting yes, I also need to confirm that the q value is greater than 2, because you know that I can cut at most k minus 1 edges. So k minus 1 is equal to 2, so k should be greater than equal to 3. So that is why q greater than 2. And then after this is the just reset operation, and so this is actually the correct solution. But on the first intuition of the problem, you could also make a bit faulty solution by directly saying like this. Let me show you that also, which I am just showing that if you thought of this solution also, then why it would not work. So this is the same part which I am doing. But basically here what I did, I thought that if the count variable is greater than equal to 2, then I could definitely output yes, otherwise no. And after this, I am just considering the case of this. Let me show you that also. That why I am saying so. You, if you don't want to listen to this solution, you can definitely skip it. I'm just telling you that why this intuition you could also get, which can be wrong, but it could be implemented using LCA if you have read it. But let me show you what I'm trying to convey. Now, suppose this node's XOR value is 0. There is some tree here and then the rest tree here. This value comes out to be 0. You need the XOR value as y. Now now you saw that this node subtree is having the XOR value as y. So you thought that if this node's value is 0, then it could be 0 only if the XOR values of all is equal to 0. So basically y XOR something is equal to 0. And recently I stated this property of XOR that if the two XORs are same, then this has to be equal to y. So after disconnecting this edge, I could definitely disconnect this edge. Disconnect this edge, then the rest part remains. Disconnect this edge, and you could definitely get two edges. But a backdrop of this is that these two nodes should not lie on a simple path. That is, the LCA of both the nodes should not be equal to that. Should not be equal to that line. Also, suppose there is a graph like this, simple graph, nothing complicated. Let me draw it some more. Suppose this value is 4, this value is 3, this value is also 3, and this value is something, anything, no worries. Now this value is 4. This value is 4 or 3, which could be said as 7. This value is 7, but this value again becomes 4. So, if you would do this CT value, if CT plus is greater than equal to 2, then this and this would get you the same value. So you would definitely count them. But what you could see is that after removing this value, you would not get this force contribution in these two, and hence this XOR value cannot become 4. So what I am trying to say is that if this value comes out to be 0, then there should be any other tree which whose XOR value should not be that same. So for this intuition, I got this wrong answer on test 42, which was at a very later stage though. So I think this solution is done here, and if you need any further clarification, you could comment down below. Uh, I have explained it according to my uh, logic, and I think it suffices for this problem. So now let's move on to the problem B. So let's start with the problem B, Hemos shopping. So basically this is just another constructive problem for which you would need observation. And in the contest where problem C and D are difficult, then solving these type of questions very quickly would get you a very good rank. But if you do not get a bit of observation, then the whole contest may get ruined. Okay, so let's start. Basically, you would be given an array A and you need to swap two elements to sort them. Basically, your main motive is to sort the array, and you could take two indices I and j, and you could only swap them if the condition this is satisfied. So you could directly see that if the array is already sorted, then the answer is yes. If the else, if the value of x is equal to n, then the answer would definitely be equal to no, because you can see that no matter no matter two indices, no matter whichever two indices you choose, you could never get value of n, because if you choose the extreme left value and extreme right value, the maximum you could get is n minus 1. So now a bit of observation, you could see it like that. Suppose this is an array, and you also make a sorted array. the copy of this array. And for all the for all the elements whose position are not the same as the sorted array, you would check that can you swap this element with the extreme left and with the extreme right. So basically the claim is that only that if you could swap with these two elements, that extreme left and extreme right, with any of them, the position of these two satisfies this condition, then you could definitely choose any third element and make your array sorted. And this you can see with just some bit of scribbling on paper, there is no fancy uh, other calculations in it. The code is also pretty simple. Let me use that. So basically, this is just the input. This is sorted copy. You sort it. This is for checking the whether the array is sorted or not. If this is sorted, output yes. Otherwise, this that condition only. That for any index I, if the array is not sorted at that position, then you check that whether you could exchange it with the first element or with the last element. And if this condition is satisfied, then it's okay. Otherwise, just output no and exit this test case. Otherwise, just output yes. So B problem is over, I think, and A problem is just nothing like maybe for just 20 to 30 seconds. I would tell you that also. So basically, here you would be given an array A, and you need to attack an enemy whose health value is H, but there is a condition that if you use your weapon once, you could not use it again for the next iteration. So you definitely need to choose this element. Otherwise, you could choose the next greatest element. So for this, you would just need to sort the array and just choose the two maximum ones. Divide this by the h value, and whatever value is, suppose you get this value as j. If this value j into this sum of the largest and the second largest, is this is greater than or equal to h, then just output 2 into j. Otherwise, it just check that if this value plus the largest value is greater than equal to h, then 2j plus 1, otherwise 2j plus 2. The only problem from which you could have learned something is problem C, and A, B are just implementation and constructive problems which you would need to practice. So now let's end this video. Thank you.